we're going to make some agents that bumping into each other with sound. So we start off with our box agent, and we're going to put some more into the scene with the place tool. Say about 40. Spread them out a little. Okay. Now they're going to have to make sound to be able to hear each other. So we start off with an output node. We put sound A in it, give it a range 0 to 100, and set it to about 44. And then we make another output node, and we call this one sound.f, range of 10,000 ought to do, and set it to about 5,000. Now if we view sound emission, we can see the circles that represent how far each agent's sound is travelling. The circles represent the distance at which the sound falls off to 0 decibels. 0 decibels means the sound is then effectively inaudible. So each agent will only be audible within the circle. And the colour of the sound is represented according to frequency. So a low frequency will be red, going through to a high frequency in the blues. And we'll need our agents to move, so we make another output node, call this one TZ, give it a range of 0 to 10, and they can move at about 3.5 units per second. So there we go, we can switch off sound emissions now. And we're going to need our agents to be able to turn, and that's going to be RY. We'll call this turn, even though the channel is RY. And our input, we need two inputs. One is sound.x, which should have a range of -180 to 180. And from that we're going to figure out left, center, and right. So we can drag these out to the right sort of range. Left should be about -120. Don't have to be too accurate. -90. -45. 0. Center should be -60. -30. And 30. 60. And then right. 120. 90. 0. And this one Okay. Well, let's set up left, center and right. Now we're going to have basically two important rules. One is if left and near, then go right. The other is if right and near, go left. So we're going to need more than just left, center and right here. We're going to need to know what near is as well. So we bring on another input node and we set it to sound.d. The range of that is 0 to 1, and it's sort of like the vision.z in that the value of 1 represents close to the agent and the value of 0 represents very distant. So we'll make this near. And put that about 0.93. And this is about 0.778, right in there. Okay, so that's near. Now we can make some of our rules. Well, first we'll add some defuzz nodes. We'll determine what left, straight and right are. Left, straight, right, plug them into our output node. Now that's got a range, should have a range of -100 to 100, and left would be a positive rotation in RY, right would be a negative rotation. And our speeds for TZ, we want slow and normal. Slow we can set to 0, and normal be about 3.5 or something. Oh, what's the range of this? 0 to 10. Yep. There we go. Right, now we can make our rules. So, if left and near go right, we'll give that a name. Left and near go right. And our second rule is if right and near go left. I'll write that in. Right and near left. Okay, let's see what happens. Well, they're not going anywhere because we haven't got any inputs here. Well, what we should probably do is set normal to be an else, so it doesn't really matter what's coming in. Normal is going to happen if nothing else is happening. Let's try that again. Oh, well, that looks pretty good. They're avoiding bumping into each other. Now in a couple of cases they do sort of collide, and what we can do to improve things is add a third rule, and that rule is going to be if center and near go slow. So we connect center, we connect near, and we connect that into slow. If center and near, then slow. Let's give that a sensible name. Center and near, slow. Let's see what happens now. That's even better. So now we've got agents that can avoid bumping into each other by sound.